All right, so this is NCCER Electrical 3, Module 1, Section 3, Part 2 of the lecture. All right, Section 3. First, we got one trade term, and we'll talk about it here in, I think it's close to the end of this section. But multi-outlet assembly. 310 loads on multi-outlet assemblies. It's the sentence that splits the columns I've got highlighted. In locations where many applications are likely to be used at one time, each foot of multi-outlet assembly is considered as one outlet of at least 180 volt capacity. 180 volt amp capacity.
Where was that at?
It's a sentence that splits the columns on page 18, so all the way at the bottom left, locations where, all the way at the bottom left, 18. Locations where many appliances are likely to be used at one time. Each foot of multi-outlet assembly is considered as one outlet, at least 180 volt amp capacity. So all you have to do is if they ask, like they go through a problem and they ask, like if I've got 40 feet of multi-outlet assembly, how many volt amps do I have to consider this? Show windows. So this would be like everybody's seen like the strip mall, like out in front of Walmart where they got like Verizon and Rotolo and all that. That's a strip mall. So all the windows they have up front, those are called show windows. Usually you have some kind of lighting on those. Usually there's some type of display in the window, so that's what they're talking about when they talk about show windows. The whole second paragraph on page 19 is highlighted. NEC section 210.62 requires that at least 125 volt single phase 15 or 20 amp receptacle outlet be located within 18 inches of the top of the show window for each 12 linear feet of window or major fraction thereof. So what does that mean? That means that by code, they have to have an outlet every within 12 feet of each other, at least 18 inches off the top of the show window. So if this big wall was a show window, 18 inches of the wall is probably like one ceiling tile off. So within that ceiling tile, they have to have a plug, and then within 12 feet of that could be another plug. So say this whole wall was a show window. This wall is definitely not 24 feet long. I could put one plug right here in the middle within 18 inches of the window, and that would satisfy that code. Does that make sense? A lot of people want more than that, but it's for like everybody's seen the open signs, like you pull the string neon sign that says open. That's what that's saying. So people don't run extension cords to their neon signs. The code is requiring that they put outlets in places like this. The paragraph that's right under that note on page 19. NEC section 220.43 addresses the computed load of show windows when calculating feeder or service loads and requires that the total load be calculated at not less than 200 volt amps for each linear foot of show window. So what that means is, if you look up at the note, I highlighted that note and pointed an arrow to it, and I highlighted it as an online test question. So just like water heaters, air conditioning, if you read that note, because show window lighting is likely to be on for 3 hours or more, it must be considered a continuous load. So whenever you do these, you have to consider each foot at 200 volt amp because it's considered a continuous load. So whenever you hear show window, think continuous load. Sign loads, 330. So this is kind of the section where they're doing kind of a catch-all. So all the other stuff like this is outside of your house and stuff like that. This is like for small commercial businesses. Page 20, the last sentence of that first started paragraph is highlighted. The actual sign load cannot exceed 80% of the branch circuit rating. All that means is to say, if I have to calculate it, if I have a sign, it's just saying if I have a 20 amp breaker, it can't take up more than 16 amps because it's a what? Continuous duty, right? So I have to, if there's so down here it says to determine the volt amp load for a circuit, multiply the amperage by the voltage, 20 amps on 120 volts, 2400 volt amps. Then you figure 80% of that, 80% of 2,400 is 1920. So I can't have a sign outside of my business that's going to take more than 1,920 volt amps per watts. That's a a ton of wattage. Like there's no sign unless you're putting like 500 of those blowing things out front. Like there's no sign that's going to take up that much wattage. 340. Keep up with the slides. 340, first sentence is highlighted. This is loads for heavy duty lamp holder outlets. Per NEC section 22014E, outlets for heavy duty lamp holders are calculated at a minimum of 600 volt amps each. Pretty much all you need to know. If you see a question on heavy duty lamp holders, however many there are, times 600 volt amps. Commercial kitchen equipment. To be honest, this one is this section is a little bit more difficult. Just 350. We're going to work through a problem together that I think you'll see on the quiz, if not the test. But my first highlight for 350 is the second sentence. NEC table 220.56 lists the demand factors for commercial kitchen equipment. So everybody go ahead and turn to table 220.56. Should be I'm going to write out a problem up here on the board. I recommend I'll either take a picture at the end of this or copy it. All right. So the question, what is the demand load in amps for 7 pieces of commercial cooking equipment with a total nameplate rating of 44.5 kilowatts with thermostatic control operating at continuous duty? Each piece of equipment has a nameplate rating of 208 volts, 3-phase. All right. So if I'm just reading through this question, what's the first thing? What's the first thing that you'll notice as far as the question?
You're looking for the amps.
We're looking for the amps, right? So I'm looking for the amps. What's the next thing you notice?
It's 7 pieces
7 pieces. What next?
of commercial.
Commercial cooking equipment, right? And then the next thing,
Is 44.5
right? And then the next thing,
with a continuous.
continuous duty, nameplate rate. I'm just going. So this is how my mind works whenever I'm going through one of these questions. I kind of pick out the more important pieces of information out of my question. So now now I need to go look at that table, right? 220.56. What does that give?
65% demand factor.
A 65% demand factor. Can anybody explain to me what demand factor means? So we're multiplying this by 65%. So just going into the it has a total nameplate rating. That's what was messing me up. Total nameplate rating of 44.5 kilowatts. So what's 44.5 kilowatts equal to in volt amps?
Yeah, 4.45.
Nope. How many watts is 44.5 kilowatts?
444,000. Oh, yeah.
44,500 watts, right? What's the same thing as watts? Volt amps. That's a lot of volt amps. That's a lot of watts. So what does the demand factor mean? What it's saying is this kitchen has 7 pieces of commercial cooking equipment. And yes, we're saying that it's continuous duty. But what a demand factor does is because I have 7. Anybody worked in the kitchen before? Ever, anywhere? A little bit, maybe. Imagine what it's like. Do you think they ever have all their ovens and everything turned on all at the same time, every single minute of every single day? No, they don't. Like never does a bakery or something have all their ovens on, all their like tables, and like everything's not operating at the same time. So what the National Electric Code is allowing them to do is say, hey, we'll say that you can take your total amount of usage and multiply that by 65%. Because we're going to say, hey, if you have 7, that's a lot for one space. You're probably only using 65% of that. Does that make sense? So that's why you have demand factors. Like that's how much demand do you actually have? So what's 44,500 times 65?
26,700.
26,700. And that's in what? Volt amps. And what is the question asking us for?
Demand load.
The amps. So how do I get amps out of volt amps?
208.
Divide by my voltage, which is 208. The hard thing here is what other piece of information do we know? It's 3-phase, so we haven't dealt with that yet. All you have to do is multiply by the square root of 3. And I don't know how to tell, like, that's just what you're going to have to do when it's 3-phase. Like, I don't know how to explain, like, how you're doing that, but that's the math in order to do that, right? So the first thing I would do is multiply. You can do everybody, like, if you put square root of 3 in your calculator, what do you get? 26,700. And then you get 208. And you said, what is it, 1.7 something? 732. Now we can go ahead. 208 times that is what? 1.732 times 708.
15,415.7.
13,000 what?
15,415.7.
4. and then divide that out. Ready?
Oh, 1.7.
Wait a second.
It's not 15,000.
Oh, yeah.
Yeah, it's not 15 yet. That's what. Yeah, it shouldn't be. It should be.
360.
120. 20.
It can't be. It should be. It should be a little over 208, or it should be like. Should be like 300 and something.
Yeah, 360.256.
360.256. That makes sense. Yeah. You do 208 times 1.732. Oh, you did 1,300. That's point. Yep, that's what it is. Sorry, I should have caught that. That makes more sense. 26,700 divided by 360.
$74.1.
Oh, we all got it. That's close.
That's 74.11.
Give me bad numbers, man. $44,500. All right. All right. 44,500 times 0.65 is 28,925. Good. Anybody see that before? Somebody sees that, like, let's shout something out so I know. Everybody messes. I've typed stuff wrong in calculator, stuff like that. Let me know. One of y'all know that I did that wrong? 28,925, right? So now we're dividing by 208 times the square root of 3. Square root of 3, put it in the calculator myself, is 1.732. That's the number we had, right? 208,925 over 208 times 1.732. 28,925 divided by 360.27. 360.27. 28,725 divided by 367. 79.73 amps. I know that was close, but we were off by just a little bit. So I know that's a mess of stuff, but you're gonna have a question like that on the test. If not that exact question. So if you have not taken a picture of that and wrote it down, please do so. I know, like, doing these questions on the quizzes and stuff like that one's gonna be hard, like that one's more difficult. But there's 25 questions on this test. That will be one of them. All right. So don't get too bogged down by commercial cooking equipment. I'm not going into it too much because it's never in my life if I size commercial equipment. Wires going to the kitchen. But somebody does that. That's why they want you guys to know this stuff. But yeah, or at least at the very base, what I want you guys to get out of this is that if you ever work, a lot of, like we live in New Orleans, like a lot of y'all might end up working in the kitchen at some point in your life. You should know that like you're not using all the ovens at the same time, so the wires don't have to be as big as whatever. Like that's what I want you guys to get. But that's the math. So going back to the book, 360 motor loads. My first highlight for motor loads is on page 21. It's right where you see, right about halfway through the page, a little short paragraph in between the examples. NEC table 430.248, excuse me, is used to determine full load current for single phase AC motors. Might be a good table to go mark with a notepad. Skip down past example 2, and then the next NEC highlight, that whole paragraph is highlighted. NEC table 430.250 is used to determine full load current for three-phase AC motors. The left column is used to locate the motor horsepower, and the capacity is then obtained under the voltage column. A 10 horsepower, 460 volt three-phase motor has a full load current of 14 amps. All right, so you'll have questions on this stuff. The next highlight I have is right-hand side of the page, right, that paragraph, second paragraph on the right-hand side of the page, whole thing's highlighted. Motor short circuit and ground fault protection is sized using NEC table 430.52. To use this table, it's helpful to know the type of motor, horsepower, phase, motor impedance, which is your full load current. That's motor impedance, like on a motor, it might say FLA, might say FLC. You usually see FLA more than FLC, full load current. But then they'd also add on a design letter if there is one. But they're going to go through, I highlighted that whole example 4. That's going to be like the question that you see on the quiz, all of example 4. So you can read through that for doing one of the quiz problems. Moving on to page 22, 370. 370, second paragraph, last sentence is highlighted. NEC table 630.11a provides multipliers for arc welders. So I just have the first part of that sentence highlighted. Next paragraph, second sentence through the end of the paragraph is highlighted. The NEC section, this NEC section applies to arc welders with or without motor generators. For resistance welders, NEC section 630.32a provides that the rating or setting for an overcurrent protection device shall not exceed 300% of the primary current rating of the welder. You want to key on for that specific highlight, you want to key in on resistance welders and the 300%, shall not exceed 300%. And then I highlighted example 1 down at the bottom. Like that's where they're going to have a problem that you do arc welders with. Example 1 is pretty much exactly like the one in the quiz. Mine will have different numbers and stuff like that. But yeah. And then if you flip over to page 24. So that's the end of the section. The only other thing that I want to highlight is there's an online test question that's exactly like number 7. So you might see a question exactly like number 7 on page 24. The only difference is the amperage, instead of 100 amps, they have 70 amps. So make sure you need to know how to do number 7. All right, let me stop the recording.